Hello everybody and welcome. And today we'll be doing a simple lattice truss. Now the model for this is this here little roof over what seems to be a stage. I'll of course link the drawing down below as always. Now we've got a simple lattice truss. One side it bolts directly to the wall. The other side it bolts into this here channel. Yes, channel. This one over here, and that channel bolts into the wall, and that's most likely for extra support. This is non-load bearing and just simply there to close up the area, and load bearing will be these RCs on the sides, and we've got a nice little PFC acting as purlins. Of course they're not really going to be purlins. There's no roof going to be bolted over this, and this is mostly going to be to hang stuff off of stage props and so forth. So let's get to it. Now, as always, first thing we're probably going to do is set up our grid lines. Now, unfortunately, to set up these grid lines, we'll have to do something that I really don't like doing, and that is measuring directly from the CAD model. Now, in most instances, especially these days, these CAD models are very accurate. Unfortunately, especially if there's a revision, sometimes the layout draftsman will take, or the engineer will take a shortcut and simply manually edit a dimension instead of actually moving the items. If it's generated from a 3D model, something like Rivet, it's not really a problem, since they'll change their 3D model and update their AutoCAD models accordingly. If it's drawn directly on a 2D, then usually they'll prefer just modifying. Okay, now if we head on over to model, we'll see that our center to center on our girders is not the same, and not even close to where our current stuff is, well, our grid lines is. So the first thing we're going to do is double click on an existing grid over there, and just check that these distances haven't been edited, and that way you'll usually be sure that there isn't a problem. The next thing we are going to do is we are going to take our current annotation set up, and we're just going to do a measurement for that one there, and the first one over here. Let's just get these out of the way. Probably just do that, not too big of an issue. Okay, then we are going to match properties and get these to be the same property, and this will give us an idea. Doesn't look like they were edited. And if we go up here, manage dimension styles, we're using the dim 100 modify, and let's go see primary factor. This stuff has not been scaled. But size is 100, that's fine, but it has not been scaled. So most likely we can even import this into our Tekla model and be able to use it, but I'm not going to do that currently. I just wanted to check my dimensions and add a few more. Let's go back to that so that we can use it. Okay, now for our dimensions itself, or our grid line itself, I am going to add the girders as well. I'm going to add them as grid lines. The 2070. This next one will be 5700, and then 670. And our naming for that will be, of course, 3, and we can either do our own name something like they've got girder 1 and girder 2. We can make this GR1 and GR2. This will be girder number 2, and this will be girder number 1. And now we've got both our own lines, their lines, and we can work from that. Next thing, we'll do the same with the length. We've got a D, E, and F, but we would like that first center line of the concrete beam as well. So do 730, 5 meters, not 50, and 7.5 meters over there. And we are going to name this something like C1, just so that it does not interfere with their C, which is already in the building. And modify that. And that should give us our X and Y. Now, for the height, we've got a underside of truss, and that's it. There's nothing else. So I'm going to use the underside of truss, and I think I'll put another level for the underside of our girders or our lattice trusses. We don't really have anything else, and we really don't need anything else. They simply need to hang this, well, put this stuff up underneath the existing. So we're going to have 0 and 1050. For our heights, we are going to say this is the underside of our girder, and the next one is going to be the underside of our truss, the existing truss. Okay. Now, when we look at our model, our visual space only goes down a meter, and that's because we've got a maximum height of 20 meters, and down it's only a meter. Unfortunately, this IP200, which is not an IP200, will extend down by, let's see, 4 meters. So I'm going to say I'd like to see down about 5 meters. Upwards, I could move this over to 10. It's not really going to be an issue. And then I'm going to modify. So we've got a deeper at the bottom. Now, next thing, I'm going to redraw view just to get rid of anything I put in, not that I put anything in, and then fit work area to make our work area smaller. Besides that, this is a fairly small structure, so I'm going to trim down these extensions to 500. Should be more than enough. And let's see, 500, and below on the Z, I'd like this to be 4 meters. And that should come in handy with our drawing. Okay, that looks fairly good. Now, for the next step, let's create some views along our grid lines. Any real views I need here will be, let's see, the underside of the truss that I'm going to use to make sure my purlins are properly spaced. I'm also going to use my 2 girders, and that should be it. So let's start with girder number 1. Okay. Head on over to edit, open up construction line, and put a construction line over there. Now, they give us a length of, let's see, 2615 this way. And that's not all the way, it's roughly half of our concrete wall over here, or our brick wall. Let's just turn these 2 snaps on, and on the drawing they do tell us it's a plus minus. Do remember that in the drawings we will need to put that plus minus in, and we will need to tell them, listen, this stuff needs to be confirmed on site before fabrication, just in case there's a problem. Now the next thing you'll notice is that we do not at any point have a direct reference from our grid line to our actual steel. Even this line over here says to the wall, but it tells me to here somewhere, and of course we are going to put a bit of space for grout, just in case the stuff isn't correct. So we will need to do another CAD measurement in order to get our measurements, and that we are going to do over here with the RC beam. 115, even if we do that, just makes it a little bit smaller, and I'm going to fit it in, well, yeah, let's just leave it above. There's not really that much space in here. Okay. Move that out of the way again. So roughly that's going to be the concrete. What I'm going to do is I'm quickly going to put in a concrete beam from our C1 side to side and from our F side to side to represent the concrete beams that are going to be in here. I'm going to make this that brownish color, and 115 I'm going to take times 230, that sounds about right, so 230, and let's make this 4.5 meters. Remember, we've got about 5 meters down, 4.5 meters for these two. That should be plenty of space to do our channel to wall connection that we need later. Let's head on back to our beam over here, and just to make sure, we're going to take a measurement. Okay. Now from this measurement we are going to put in another construction line, and with these construction lines we are going to get the points on our purlins, not the not the lattice girder or the lattice truss itself. We'll need to do some more site measurements or CAD measurements to get those exact values. For now, this should be good enough. 100,475, and that goes all the way up to the end. I don't want to count, so I'm just going to put 10 in. Probably need to select it first, and there we go, all the way up to the end. Let's just do a measurement over here quickly. That's good. And then from this line we are going to do a copy of 1562 as our plus minus point, which is over there, and that'll give us the start point. Okay, next thing I'm going to do is I'm going to take these two and move them on up to the underside of the truss, as the truss girder will be bolted against it. Now, for our members, we are going to be needing 200 PFCs. I'm assuming this IP200 is also going to be a 200 PFC, just because, well, that should be obvious given how it bolts to the wall. Now, this side, as you can see in the CAD, well, in the Tekla model, CAD definitely, we've got a bit of a space there, and there's actually a little bit more than normally I would feel comfortable with, but it's definitely within tolerance. Most likely this wall is not the best or not the most accurately built, as is often the case with this type of thing. And this side, we've got a definite. Now, I think the reason they left that much space on this side is because they intend to bolt this to this wall, bolt the truss to the support, and then whatever's left is left. Where normally we would have a space for grout on both sides. But anyway, now here we are going to first put in this connection part so that we can build the truss off of that. Okay, the part is 4050 long. So let's start off with that over here. If we look at our model, it does not perfectly line up, so we're going to start off with a nice line at our top of truss. Now we're going to copy this down by 200. Go get our steel, and we're going to say we're using a PFC 200 by 75. So much for my spelling. BC, okay. 200 by 75. And we are going to rename this from what it currently is as beam to support. Support column SC. Green is good enough, and then from top, doesn't really matter where. We are going to do it at a total distance of 4050. After that, let's quickly flip this to the side. To take it around back. Great. Back's against that. We are on behind, and middle should mean we are in the middle. Excellent. Now from here I'm going to move it down to 200, and then I'm going to have a quick look at my drawing. Now my drawing over here shows that truss is bolted to this plate and sticks out. Over here it shows that the plate ends roughly there and then 170 up. So I'm going to take this and move it 170 up, and that looks roughly like what they gave us. From here I'm going to go over to my bolt, put it on this, and just put it in from top to bottom, and that's going to give us this one over here. Now they say that these bolts into the wall uses 20 diameter 18 holes for M16 bolts. Now obviously these won't be M16 bolts, they will be something like a chemical anchor. So we are going to go over to a chem set. It might be Latice or something else, but it definitely won't be a normal bolt. Let's take this and just swap it around. It really doesn't matter if what way it sticks or shows, but to me it's going to look better if it's not protruding through my truss. And then from here we are just going to have a look at our drawing and enter the same values. It starts at 80 down. Nowhere does it give a cross center, but I'm going to estimate it at somewhere around 90. Put 90 in there. Modify. Let's head on over to the 3D. This should look a lot nicer here. Let's take these two walls and just extend them a bit. 750 should do. I'd like them just to be past our connection point. Over here we can see our bolts. So let's take them and continue down. Now I'm just going to use this one command for my bolts, but if you do prefer, you can definitely do multiple copies down instead of filling everything in the same command. To me, this is just a lot neater and a lot easier to change. 965. 100, 570, 570, and then we're going to end this off with another 100. Do note that there is a limit to the amount of distances you can type in here. So as long as it's under that amount, I really prefer it this way, as I can simultaneously edit everything. If I decide I'd like 100 instead of 90, everything changes all at the same time. Now, the reason I'm doing this as 100 is because if I look at the other side, bolts to the wall, it says 100. So even though they don't say anything here, as always, the easiest, the most neat option is just doing everything is the same. Next, over here at the 200 down mark, or the 170 from top over there, we are going to put a plate in that is 200. 200 over there. Now, fastest would probably just be to load up the plate. I'm going to make this plate a grey color. According to their note, this plate is 12 thick and as wide as the channel it goes into. We're going to need to swap this to front, and it is still in the middle and the back is to it. Next, of course, we're going to put some bolts in it. Again, this is going to be an M16, and we're going to leave it at a 4.8, I think. Let me just give a read through. They don't give us a grade. Usually, M16s will be a 4.8, M20s will be an 8.8. If you are not sure, make it an 8.8, then you're safe. Always better to be too strong than too weak. Of course, they might cost a little bit more, but if you've got multiple grades of the same size on a project, do everything in the one grade that's stronger, as buying one set is usually cheaper than buying a lot of different types and sizes, with how the whole bulk thing works. Next, we are going to copy this with a space of 150, so 350. And since I don't trust my own math, I'm just going to take a measurement. That should do. Now, this one here in the middle is only a single set of bolts, and instead of 200, it's a 150. So I'm just going to make this 50 shorter, and I'm going to change this to 75. Let's take that away. That will be the middle bolt. And then we're going to copy this top one, 500 plus a 150, so 650 over there. And as far as I can tell, that's exactly the same spacings as we do have there. Next, we can start off with our truss, finally. And for our truss, we can use the exact same channel that we've got over there, as the top, the bottom, and the sides will be this 200 PFC. Call this girder. I'm going to call this LG as a lattice girder, and I'm going to change this color to be a light blue. Even though it's the same section, I prefer having a visual distinction. Makes it look a lot better. Now if we go all the way over to this side, we are going to get our grout, head on up and head on over. Now with this one over here, you can see perfect. This one at the bottom, all that will need to rotate 180 to face upwards. If we changed our axis to be on this view, that would not have needed to change. Everything would have been facing inward, since we're doing it in a clockwise direction. But I like it this way. Now, if we take a look at the way they portray it, basically these ones will be slotting into the tops and bottoms, something like a weld prep connection. Something like that. Of course we're going to set it so that it goes all the way, obviously. Now the other choice for a connection like this, or a corner like this, would be a crank. Let's head on up and put it at the top, and you can see the difference between the two. Now personally, for this specific type of girder, I think the crank is going to be a lot nicer, a lot easier to work with. So I am going to change it over to the crank, and that'll be for both sides. Okay. The next thing we'd like to do, let's head on back to grid 1. And before we forget, is change these bolts to be both in the plate and our PFC bolt parts. Next, while we are busy with this stuff, I'm going to open up our main one over there, and that's so that I've got the chem set and stuff, and then I'm going to just put it into this side over here. I'm also going to be changing everything anyway, so the settings doesn't matter too much. Let's just quickly remove all of these. 50, 100, 2 times 275, and finishing off with 100. Modify. Alright, we started off with a 50 instead of 50 space. Okay, and turn this around so it's facing outside. that should do it for that. Now, next thing we'd like to do is start off with our lacings on the inside. All of our verticals are going to be 50 by 50 by 5 angle lines. All of our diagonals are going to be 60 by 60 by 6 angle lines. And everything is going to point inwards to the center. Let's go up to beam, and we're doing a lacing. That is needed for our section size. 5. And put it in. After putting it in, I'm going to change the color to 6 just to give me a nice visual difference. Next, if we look at it in our 3D, I'd like it to be right. I like it to move this way by right. Another 5. That's half of my gusset plate I'm going to put in here, and then from the back I would like it to move onto my centroid. Just go back to 1. So we're going to head over to select our profile, go to analysis, and we're going to look at radius of gyration. That's 15.10. So from the back we are going to move it 15.1 at a minus, and that ensures our strongest line for bending, where the forces are worked out. From here I'm just going to take it and copy it to all of these lines. I already have them in as construction lines. If you don't, you could put them in or do a copy special linear at 1475. Next, we are going to do the diagonals 60 by 60 by 6. Corner down to there. To make the visual distinction, I'm going to change the color again. And I'm going to change that 15.1 analysis to 18.2. 18.2 to get me at my centroid from the back over there. Great. Once this is done, just remember to apply that. And these are from the top to bottom, top to bottom, all the way up till grid line E. Once we reach grid line E, we are going to do from bottom to top and continue on. Let's go back to our isometric and have a quick look and make sure all of our lacings is on the same side. Yes, they do appear to be on the same side. And now we can quickly do our connection. For that, we can either use our welded gusset, which is number 10, but unfortunately a welded gusset cannot see the two different sizes between these. It's only set up for one size. So for this we are going to use a bolted gusset, with a slight trick to it. And for our bolted gusset, we are going to select firstly our vertical member and secondly diagonal. Order of selection is quite important when doing the settings for this. Firstly, 20 clearance, that's good, that works. Secondly, we would like to choose this one over here, just a fairly square plate. We don't really want any of the cut-offs, as this is going to be inside a truss. Keep it very simple. Next, we're going to take the bottom one over here, and that allows us the correct shape. Now, while the other option does make for a bigger plate, this one prioritizes the first one we picked, makes for a nice, more compact plate. Next, we are going to come over here to bolt brace 1, and we are going to say it's 50 times 1.5, so that's 75, and the rest of our values we are going to make 0, and that's going to remove the bolts completely and make my distance 75. Next, 60 times 1.5, that is going to give us a 90, and we're going to make the rest 0. Remember, the strongest connection is 1.5 times the width of our angle line, or our recommended strongest anyway. And that we are going to apply and use just about everywhere, minus our center, which most likely will need to get fixed up, as well as this side. So let's change our selection to object in selection, so that we can take this plate and just move it up to against this web over there, and that way we don't have to explode it for now. If you're going to copy this over to the other side, do anything that causes this connection to regenerate, you will have to explode it. But usually you can wait till you're done with the other connections to make sure that you don't need to adjust it any further before exploding it, as adjusting it afterwards can become a little bit of a pain. Let's continue on. And these are just fairly simple connections. Only real one that can cause a bit more of a headache is the one in the middle, as I said, and that's simply because we never set up bolt brace number 3, which we can do now. We just need one of them to be 1.5 times the width, so one of them would be 90, and the other 3 will be 0. I'm going to leave the center for now as well, and just do the other ones that I know will work. Now, the next problem caused by this wonderful connection method that's got multiple different sizes for the different sides is that it does not weld. Welds the plate to the main item, as you'd expect, but if we go over to assembly, it does not weld the bracings to the whole thing like a welded gusset would. To do that, we are going to select weld, take our topmost one over there, and just do an area selection inside. Let's quickly have a look here, and wonderful, we've got now everything in the exact same component. And just to make sure we've got the correct member as our main member, we are going to pick the top or the bottom and say set as main part of assembly. Now let's do this top one over here. Now, problem over here is that this is a very narrow, long plate, a little bit flimsy, not very desirable. Now, usually with a bolted connection, we'll flare out these sides using these two commands with a 30 degrees. Now, because we are using a square plate, it doesn't really work that well. What we are going to do though is just add a 20 to the sides and widen that plate up some. And that will provide the rigidity we need, as well as a bit more welding area. Now, like we did that there, we can of course go to these others and just add a little 10 over here to these three to make them a little bit wider, and that's going to give us a little bit of space here to do some welding. Just do an area selection over there, that one over there, and all of these over here. Undo. We don't want anything done to that center. Now, everything's got that little bit sticking out, except for that one's got a bit more sticking out, providing enough space. Everything seems to look good. So I'm going to go over to isometric and I'm going to redraw my view, and that's just to get rid of all my cuts and fittings, as well as weld symbols. I might even go as far as to get rid of the component symbols, so that it's nice and clean. Once that's done, I'm going to go back to setting assemblies, and I'm just going to check that I've got that one over there, and that's the only two parts I have so far. Let's get a top view with Control P, and then copy these two items anywhere over there to perpendicular this side. Expand. As this is our isometric view, we should be seeing everything at all times, so expanding is fine. And that'll give us our two lattice girders. Next, we are going to need to put in our purlins, these 100 by 50 channels. And for that, I'm going to put one single beam at any point over here, and I really don't care where I put it in, it's not important. Let's head on back to our girder 1 section. The reason it's not important is because we can move it in our side view to get it up top. From here, I'm going to load up my standard beam, make sure I've got the correct marks. PU, call this a purlin. And we are going to use a parallel flange channel, in this case a PFC called PC, 100 by 50. Also going to move this to be front, and then I'm going to quickly have a look at orientation. Now, everything on this side looks inwards, and everything on this side of E also looks inwards towards E. Next, these dimensions are in the center of my channels. So, center of channel and looking towards E, I'm good. I'm also going to take this and let's just make it 13. give us a nice orange color. And then I'm going to copy this over here, where I can take it and run a swap handles on it. Turn it around so both of them are facing inwards. Once that's done, quickly do a connection. We are going to use gold rule overlap number 1, basically the same as we would use for a normal purlin. The big difference here is firstly, well, the size of the item. Next, the amount that it sticks over, which is half of this, so 100 only from the center. Again, to be flush. Let's have a look at our T section. What do we need? Well, usually 4 bolts per end connection on a purlin, but that's because we've got multiple bays of purlins. Since we've only got a single bay, and we do have a minimum of 2 bolts per end connection, we can do just a small plate with only 2 bolts. So we can either go and load something, or we can change this to be a plate. Let's see, PL 10 by, just pick 100. Okay, so obviously 100 is my width. Now I'm going to say, okay, I'm going to use the same cross centers I've been using over here, and that's just going to make everything look very nice and, well, fairly the same, regardless of what would actually be preferred. So we're going to say 100 cross centers plus 30 on a side, so 160. That should be good. Next, we are going to say, well, we don't want this directly on our channel. We do want a space of 10, and that space of 10 is so that our connection can weld on the inside, and that's going to change our distance from our bottom to our bolt, which we are going to make. We're going to put the bolt directly in the half of this, so directly in the center of this channel, and that way you can flip them over upside down, doesn't really matter which way around, and they'll fit in. Much easier to work with. So we are going to say 60. We only need 1, and we can leave the 25 at the top. This here we are going to change to 100 and modify, and now we've got this ugly little low plate that goes in there. Now an 8 would probably work well, but since we've got a 10 over here, and let's just quickly, so since we're using a 10 over here, we're going to use a 10 over here. If we used an 8, we'd use an 8, and so on. And that sameness, even though it's a little bit of a heavier connection, just the fact that both sides is the same is going to reduce costs. That all plates are the same. Let's go to number 1, grab our purlin, and then just do a perpendicular copy to the ends, the end over there. Grab this one here and do the same for this side. There we go. Now let's head on up over here and make our drawings. Firstly, we'll do our numbering as always, and then run our let's say cheetah bee landscape, create from all. Now normally this is about 14 and a half, almost 15 meters long, so we would usually split it somewhere, preferably somewhere over here for the top and over over here for the bottom and do a nice little splice connection, add this in as a bolted member, something along those lines. Now, anything over 13 meters usually requires special transport, specific trucks to get it around, special permits to keep the for the trucks to be on the road in any given area. So anything over that you would splice unless you've got permission to not splice. Might sound silly, but it generally equates a lot more expensive to use than a regular transport trucks. Project properties, I'd like to edit this, project number, that's 1011-S. The project name for this would be Block C Renovations. So Block C Renovations. Client is marked as CAID. The title block is that. Description, this is just a stage grid. Site address. No, wait. Client is given as Waterfall Teachers College. Okay, Block C Renovations, Waterfall Teachers College, stage grid. I don't really have a site address. I could always break this up, make it Block C, keep that as renovation, but I'm going to keep that singular and just remove the address altogether. Doesn't have to have anything filled in, but if you aren't going to have anything filled in, best to blank it and just get rid of it altogether. That looks fairly comprehensive. Next thing I'm going to do is I'm going to change this to an A2 drawing, as I want all my main drawings to be A2. Call this Berlin. I'm going to modify. If we bring our drawing list back, you'll see this is a 12 by 554. Now, when it comes to our metric paper sizes, that is not an A2, that is an A1. Do be careful, even if Tekla tells you it's an A2, yeah, it might not be one. A lot of this stuff isn't set up properly or correctly, depending on the region you are in and who is in control of your environment and such, or your company's file setup. Normally that's not an issue. You come over here to layout, just type in the new value, modify. You'll see we've got a bit of a smaller drawing, and if we have a look here, we'll see that, well, it's not an A2 anywhere there, so we are going to say A2L and just save this. After that, we can go to our folder options and just make sure we copy this save file to our main environment so that next time we do have an A2 to work with. Now, it won't be updated here up until you press save, then it'll change. Let's head on over to our column, well, our support column that gets bolted to the wall. We're going to do the same thing over here. I'm going to load up a full A2 and I'm going to call this support column. There we go. Modify. Now problem is if you make any change like loading up a new size, Tekla would probably give you stuff outside or views outside, and usually that can be fixed just by right clicking and arranging the view. Now, as you can see, there is no section view added, even though I've got a full assembly selected, which usually is supposed to come with some section views. You can either go and put them in yourself through view, and I think I would like a section view to show that this comes onto the flange. The other way is we can try and induce it through view creation. Now, a lot of these are on auto, so the program decides, and we can just force it by putting it on. Yes, it will be recreated, and now we've got our front view, and we also have a top view for some odd reason, although it doesn't really help because they've started to make the hidden lines, well, more than just hidden. Okay, let's go to part and just turn those hiddens on. Now it looks like a part from the top. Wonderful. And again, we are going to take our view, select that, just move it somewhere else so that Tekla's got space there to put it in. Right, before I head over to the truss, I'm just going to have a quick run through all the other drawings to make sure there's nothing odd about them, and to you it will look mostly like a flashing screen, and that's fine. If you've got parts that you don't really like how they put the dimension, although only the first two dimensions are really needed, that one obviously is going to be whatever is left. I usually do prefer having them complete. And of course, sometimes the client would prefer it like that, as it looks neater. For you, just do what your client finds best, or what your the workshop you're doing that's going to fabricate this, what they would find most convenient. Right, the next thing is this one over here, which is just as bad, and you'll find that usually with complex assemblies like a truss, Tekla often can't understand it, so instead of doing a reasonable scale, they'll either stick it to a 2.5 or in this case 5. What I find best for this type of drawing is to start off with a assembly no dimensions. Just get rid of everything that you don't need. Now, as you can see, it does change our view a little bit. It takes away our coloring that we had, and I'm also going to take these, delete that, undo. I'd like to keep the top view and delete everything else. Next, I want to open up this, make sure that is a 15, that is a 15, and then I'm going to have a look at my paper size, and that is an A1. Now that's an A0. Well, I'm thinking let's try it at an A2, and you'll see there's a big difference. But of course, as soon as we made this smaller, Tekla changed our 15 to A5. Do that at a 20. Arrange drawings. That's not going to fit in anyway. So let's do this at a 25. And that's still not going to fit in, and I don't feel comfortable making this any more than 25, so I'm going to go back, open up my layout, and say, right, yeah, that's not going to work at an A2, so I'm going to go over to an A1. A1 is fairly simple, it's just 821 by 554. And now that we've got a little bit of a bigger drawing to work with, we can go back down a few scales. Let's see, I think 15 is definitely going to be too big. Hopefully 17.5 would be a sweet spot. No, okay, so this will have to be 20. And as you can see, guessing it right off the bat what size would work best, you can get quite good at it after a while, but sometimes, and especially in the beginning, a lot of guesswork doesn't hurt anyone. Next thing I'm going to do is I'm going to take all of this and I'm going to get rid of these center lines. I don't want center lines, they look horrible, especially on this type of item. After that, I'm going to turn off fillet edges. I don't want 15 lines denoting what way this thing faces. It, again, looks horrible. Apply. We want just the 2 lines showing what side the flange is. If yours still shows a bunch of lines, you can change it from exact to workshop form, and that should also get rid of a lot of the lines. Next, I'm going to turn on own hidden, as that's so that I can get these internal lines just to give me a clearer picture and a cleaner picture of what side my web is. Then we are going to take all of these internals and we are going to use a reference line. Now remember that line we put the command in with, or the command line we put the lacing in with, and then we moved it around in the settings, and this is why. That line we put in with is the reference line. That'll be the line over there, and that's from what we offset. And that's quite useful to have that in the correct position when doing something like a truss, as you can use that to get reference points. Now, what's the reference points for? Well, ease of dimensioning. Instead of having a large amount of dimensions, stick this up there, make this visible, and change this equal combination to no, as using that can, well, it's got a time and place for everything. I don't want these to combine like that. Lovely on stairs, but I prefer to have singular dimensions, especially on something like this, because I'm going to put in a couple of typical dimensions on different spots. Now, if you're like me and you sometimes often, sometimes seldom, click miss, you can end up with extra lines, which is not a problem, you just remove them. Now, for these extra ones here, I'm going to take that and I'm going to say 25, and I'm going to make that a typical. Put that up on this side, see what it looks like. 25 typical, and these will all be the same. Now for the ones that aren't the same, we will need to give a dimension, and we are going to use the exact same side. So that side over there, and I'm going to make them roughly in the same line. And roughly in the same line. Just a middle click to put it down, and that'll make it easy to see where they should be. Next, of course, I'm going to do a couple of other typical or typical dimensions. firstly would be that 10 over there. Then it's going to be from the back to there and from here to here. These two ones, which of course are going to be typical again, are my centroids or my neutral axis, my duration, and they are going to be a little bit more precise. So I'm going to say I'd like it to be 3 values, but I'd also like it to have a point something if there is something to be pointed. And I don't want it at 3. I'm going to make it just 1. Good. So I've got 18.2 and 15.1. After that, as you can see, Tekla did not adjust the typical outwards because of that. So we're just going to put a couple of spaces over there. Maybe take it off completely and just put it as a postmark on the item itself, and that way we get it outside of that text. Here again we are going to also do the typical 10, as we'd like a 10 spacing. And let's move it over there. We can move those two spacings, something like that if you want. You can even put the typical in brackets if that is your preference. Okay. And by doing that specifically, we don't really have to give a position for any of these plates, nor do we have to tell it where these start or end, because we've got a typical value on them. I'm going to do the same for over here and just get a typical 20 clearance and a typical clearance over this side. And again, this is nice because all of these end up being the same. If they're not the same, you can add that to your dimensions, but as long as they are the same, you do not need to add them separately. The easiest way to see that will be part marks, as anything that is different will have a different part mark than the rest. Since all my diagonals are 8s, I know they're all the same. 7 and 9 on the edges, and that's mostly because of what's going on over here. And that'll be the same for the centermost one, while all the other verticals should be the same. This one over here is going to be different. It seems this one's also a little bit different. And the reason for this one being different, obviously, again, is just because singular. That's just for the 20 over there. Move it to the side. And that's fairly, I think, all the dimensions we are going to need. After that, I'm going to double click on this, open it up. I'm going to say 10 scale, but I'm not going to change or apply or anything like that. Well, I'm going to apply, I'm not going to modify. And that's because I would like the exact same settings, but a bit larger scale for my section view. Now, I can go and put in a dimension, giving the height here, but I'm going to do one over here, simply because, well, space. Don't have a lot of space, don't want to force a lot of dimensions into small space, and I've got a lot of empty space over here that really doesn't have much use. Now, obviously we can see this hidden stuff behind, but I don't want to see it, so I'm going to take it and hide it. And that'll change it to a non-printing layer and allow me a clearer view of what's going on. Next, I'm going to open up this, and I'm going to add own hidden lines again. And that's just so that I can see these lines. I unfortunately also get these that I don't want, so turn fillet edges off, and that'll give me a fairly neat looking view. Let's go to dimension, and here you can do an overall from top to bottom, another overall from hole to hole. Well, not really an overall. You can do cross centers, center to the sides, and we don't really need to give these last two bits either. And this is a good side view to use. Now, as I'd like both sides to use the same set of icons, I'm just going to add a section mark to it instead of adding another section. And I'm going to have these both be A. So, from the sides, both of them is this. We can also add another section view, probably in the middle somewhere over there. That will look nice. And we can now add a bunch of these symbols telling each of these they are B, or we can open up B and just say that it is typical. Typical section. Through this, nothing serious. Now, your Tekla might do something like this, and that also happens quite often. So, just for ease of use, I prefer to just take general text node, stick it down there, well, outside the node, typical, and then just bump it down just there. Next, I'm really not going to do much to this one, except put a couple dimensions that I've already got here in there, maybe add 25, and here just do those, and then these two. Now, as you can see, these don't look great, so I'm going to move them outside. Go. Move this one a little bit down. Go. And this looks like a lot more of our traditional way of doing it. And it looks quite good. Now, these ones you can either put there or roughly in the middle here. Whatever you find that it looks fairly neat, not too bothered about that. And that's going to give me all the information I need to fabricate this part. Save this. Lastly, what we'd like to do is our GA. After, of course, we just change this name from assembly to Latice. The reason I open up the drawing to change the name instead of simply going to the properties over here is because sometimes, just sometimes, the program will regenerate the entire drawing instead of just changing the name, even if that's the only mark you've got ticked. Something to be careful of. Great. Now, let's double click on the background, load up our standard, and I don't really like it that way. I'm just going to give it a slight twist so that I can see these members over here, and I'd also like to see these lacings and everything, and yeah, that actually looks quite good. Yeah, it looks quite good. So when I create my GA, that's what I'm going to use. I'm also going to have an underside girder or underside truss. Doesn't really matter which one. Both of them I'm going to just set to see through. Doesn't matter which I pick. Then I don't need a section on both girders. So I'm just going to pick one, and that's going to be my section. I'm also going to get a section on, let's see, grid line F over here, just to show what's going on with these. Maybe C1 as well, doesn't really matter, it's not important. Let's create and open the drawing. Now, firstly, what we are going to do is basically what we did on our 3D. We are going to change this down to about 4 meters. Remember, we loaded the standard, and when we loaded the standard, we lost that depth. The next thing we are going to do is select everything and just get that nice dark colored in haze back. So full, solid, special. Everything just looks that little bit better. Do make sure this is not selected, as it can mess up your depth. This case didn't really matter, luckily for us. After that, I'm going to take this grid line F and delete it. And that's because it was showing me from the back. I would like to see it from the front. So instead, I'm going to get a normal section view by firstly opening up this and just applying it. Remember, last we applied, we had a normal assembly drawing view applied. A little bit different settings, a lot different scale, so that should work. Next thing is again concrete. We do not want the concrete as dark. We would like to show that it's existing, it's already on site. We are only bolting to it, so we are going to make a nice dotted line and remove the fill. None, and that's going to give us a very nice visual distinction, visual difference between our steel and the concrete, our new stuff and our existing stuff. Here you'll see it's still partially colored in, and that's to do with it being cut through a section view. So that doesn't really matter, that should not influence anything. Then we are going to take and make that a little bit smaller, and we'll put these two next to each other. And that's just to see roughly how they fit in with each other. If we make this a 45 scale, how is everything going to fit into the drawing? It's still going to fit in nicely. Maybe not as clean as a 50, so I'm just going to undo it, get it back to the 50s, and that's usually for me the easiest way. I just play until I find a scale that works nice with my page. Now this is a fairly small structure, so only one drawing is needed. When you're doing drawings, even if you've got a massive building, try not to have a scale larger than 75 for your individual views. If you do need to go larger than 75, do an overall 3D of everything, or an overall roof of everything with the dimension to the different grids, and then do a larger section on each grid showing the individual parts. Put that up there, put that down there, and apply our new 45. section view. Showing what's going on this side, as well as the exact same view showing the other side, because why not? Again, I'm going to change, let's just make this wider, same over here, wider and wider. I'm going to use this setting we made previously, just to grab both of them, and of course at the bottom as well. Now at the bottom I don't want it showing the cut off line. In other words, I don't want it showing that line over there on where the concrete stops, because, well, it's on site. I don't know where it stops. This needs to come in. Doesn't matter how far it shows out. I can't have my symbols outside of my physical drawing border. Okay. Now that looks fairly okay. And of course, I would like to have these two aligned, even though they're not technically aligned, or the same way around. Now, for dimensions, we are going to put in a couple of dimensions just from our main grid to our main grid. Remember, these custom grids you put in for yourself and nobody else. Even though they are very useful, guys on site need the existing points to work off of. So, a set of main dimensions showing up, well, showing the existing ones, and then a secondary set if you've got them in line. That's not an issue. If you've got them like this, you'll give the main set and then the secondary set underneath that. Over here, I'm just going to give the 30 as well as the bottom over there. And with both of these, just a dimension, not too much information to give. You might give a height right over there, 200, just to show what's going on. And of course you'll give that same 200 over here, but with split dimension as well. And again, this side we are going to put in our overall as well as inside points. Up, we've got a lot more space. Nice overall there, way up there. Alright, next I'm going to do the exact same dimension they gave on the layout, which is from center of purlin to center of purlin. The reason for this, even though technically they've got the part, they don't really need this dimension, is purely for checking purposes, to be honest. It's more to do for the sake of the engineer that has to check this work, the layout draftsman that has, or the senior draftsman that has to check the work, than for your own purposes, as you always want to have, make it easy for whoever has to check the work to be able to do that. And of course I'm going to add that one over there. Let's just lower this down a little bit, make sure we're not taking up over that. Ahead of this, I'm going to load my plus minus symbol. easiest I find is just to open up something like Word or Internet Explorer or Firefox and just search the symbol. But in this case, it's actually very, very easy. What we're going to do is we're going to go back to our CAD drawing, just double click over here, and they've got the symbol in there. Select that, copy, come in here, and we'd like to add it to the front as a mark. There we go, plus minus. And here we are going to add a dimension for that. And this dimension we are going to make hidden. The reason we do that is because we've got a plus minus up top. We're just going to call this ground. So we do not have the site dimension for this. If we did, we could give a nice precise amount. We could give ground both sides. We wouldn't have to give a plus minus. But unfortunately, we do not have site measurements. This stuff still needs to be gotten, and as such, up until the point we do have the exact information, we just give it as they give it to us. And that should be it for the GA, except part marks. Most important part, almost forgot it. When giving the part marks, do remember that only the assembly mark is really needed. The rest are nice to have, but not critical. In other words, if your program decides to give you a whole bunch of other crap as well, only the assembly mark, assembly position is really needed. The rest of the stuff, nice to have, makes it easy for the guy checking, but secondary information compared to the assembly mark. Also, CB1, I'm going to delete that, and I'm going to delete this side as well. Again, the concrete beams are just for reference, our own reference, and looks nice for the client reference, but not something that they are going to make, not something that you are going to make a drawing of, so not something that you are going to put in. And that's it. Hope you enjoyed, hope you learned something. See you next time.